Hello wonderful person, this is Anton, and well, let's discuss some of these viral headlines in regards to Earth spinning faster. Something that a lot of different news sources have been trying to cover, and something that, though to some extent somewhat correct, is also extremely easy to misinterpret or to misunderstand. And so in this video, I wanted to briefly discuss exactly what we think is happening, why none of this actually very likely matters, but also why this is still kind of interesting and somewhat intriguing. Intriguing because in 2025, we do have these 3 separate days when Earth is supposedly spinning just a little bit faster than it should. But because this is such a tiny insignificant blip, none of us will ever notice it, and in the long term, none of this will actually matter that much. But these changes still matter for some of the most sensitive technology on the planet, and so it is important to understand what effects all of this might have. Because here, for the first time in history, some researchers even proposed adding what's known as the negative leap second. And so let's discuss this in a bit more detail and talk about what's potentially happening. But first, let's discuss these leap seconds, just so that it makes sense. Now, I think most of us are familiar with the leap year. The idea that every 4 years, we have to add 1 day to the calendar, specifically February 29th, in order to match our calendars with the actual orbits of the planet. And that's because, technically, the astronomical year lasts 365.25 days. It's not exactly 365 days. But what most people are not familiar with is, of course, the leap second. This is an adjustment of just 1 second that's now been done 27 separate times since 1972, and that also results from something that happens to our planet as a result of its orbit. And in this case, we're talking about the co-orbital rotation of Earth and the Moon. As the Moon spins around the planet, it actually slows down Earth's rotation just a little bit. And so occasionally, 1 second is added to UTC, or Coordinated Universal Time, to keep it synchronized with the Earth's true rotation. And if you've never heard of Earth slowing down its rotation, you might want to check out some of the previous videos where we actually talked about geological evidence, where we know that during ancient periods of Earth, the days on Earth were much faster, as fast as 23 hours just a few 100 million years ago, or as fast as 17 hours approximately a billion years back. These videos should be in the description. And so, since Earth's rotation is influenced by so many different factors, with the biggest factor being the Moon, generally Earth's rotation is supposed to slow down very gradually. But there are obviously other factors too. For example, the movement of molten iron inside the core, and even the distribution of water on the surface. And so as a result, the overall length of a day has actually fluctuated quite a lot in the last few decades. And so the International Earth Rotation and Reference System Service, also known as IRS, has been continuously monitoring all of this and, once in a while, adding 1 second. And in case you were wondering, the last one was added on the 31st December 2016. But bizarrely enough, in the last 9 years or so, not a single second has been added because for some reason Earth basically stopped slowing down. This is actually a pattern we've been observing for the past 2 decades, and we've actually reached a point where this is the longest period in the last few decades where not a single second has been added so far. And so even though on average the day is still 24 hours or 86,400 seconds, in reality each of these rotations is always just a little bit different. But here, just to highlight this again, since 1972, the day basically got 27 seconds shorter, which is actually kind of mind-blowing when you think about it. But since 2016, something bizarre has indeed been happening, especially since 2020. And that's because that was the first year when I've actually talked about these bizarre effects when the Earth was spinning, surprisingly, just a little bit faster. And it's continuously been setting these new records in the last 5 years. And actually, the shortest day so far was on July 5th, 2024, when Earth completed a single rotation 1.66 milliseconds faster than 24 hours. And yeah, that's 1.66 milliseconds, which is about 20 times faster than the cat's reaction time when it comes to swapping something with its paw. But when it comes to these ultra-fast days, 2025 for this year, so far has been the most remarkable, because we actually expect 3 separate days. July 10th was one of them, when the day was 1.36 milliseconds faster, but also July 22nd, which was just yesterday from when I'm making this video, and the next one is going to be August 5th. And these very strange acceleration trends are kind of difficult to explain, but have been happening more and more. As a matter of fact, it has been reported previously, going back a few years when this was originally discovered. And you can obviously see it right here in this graph. And I guess the first question is, so what does it mean for us in real life? Well, for you and me, personally, nothing. For cats, with their super fast reaction times, also nothing. But these tiny discrepancies, in the long run, can definitely affect modern technology. Especially because modern society relies on incredibly precise timekeeping. Computers, satellites, telecommunications, obviously the financial sector, various electric grids, and of course the GPS, all rely on super accurate time, usually in milliseconds. And for most of this timekeeping today, we normally use atomic clocks. Originally introduced in 1955, these incredibly precise devices can count oscillations of atoms in order to calculate 24 hours to incredible precision. And so what we actually call UTC, or Coordinated Universal Time, is technically an average of 450 atomic clocks around the world that are used to create a global standard that then all of our computers and all of our smartphones use to function. And so when Earth's spin changes too much, especially too much compared to this atomic time, we very often have to rely on these leap seconds in order to maintain stability in this UTC system. But now for the first time, we're basically facing the opposite problem. Instead of adding a second, or these leap seconds I've discussed previously, if Earth keeps spinning faster and faster multiple times, we might actually have to remove a second from UTC. And this is what the scientists refer to as the negative leap second. And this could be a big deal for, I guess, technology. Mostly because it's never been tested before, and it's never been done before. With several scientists, especially the ones from the National Institute of Standards and Technology, highlighting that even with these positive leap seconds that we've been adding for the past 50 years, there are still ongoing problems with systems that are not able to implement them correctly. And so here we can only imagine what would happen if a second was removed, especially if something goes wrong with the global system that's never encountered it before. Here this was kind of compared to the famous Y2K problem that happened on December 31st, 1999. And though this by itself didn't actually result in any major crashes, it still created a lot of uncertainty. And quite a lot of scientists actually believe that we might have to do this sometimes before 2029. Once again, mostly because of what you see right here. This unusual increase that's been happening in the last 5 years may eventually result in the introduction of this negative second. But then we have this obvious question. So what's really happening? What's causing the Earth to spin faster? And this is where it gets just a little bit interesting. Mostly because we don't really know, but there are quite a few propositions. But we know that it's probably not from the moon, and also not the tides. But we do have at least a few propositions. First one is, well, maybe it's something inside the core and inside Earth itself. And that's because we also have studies suggesting that for the past 50 years, Earth's massive liquid core has also been slowing down in terms of rotation. And so here we have the obvious laws of physics when it comes to angular momentum. If the core slows down, the solid Earth around it has to speed up to compensate. So maybe this is just a redistribution of angular momentum as a result of dramatic changes inside the core, whose origin is also currently unexplained. Or maybe it's all because of the atmosphere. Short-term fluctuations from atmospheric changes and various seasonal changes, such as, for example, jet streams moving north to south, can also cause the atmospheric layer to slow down. And again, in order to conserve momentum, Earth would actually speed up. Not by much, but enough to cause these millisecond changes. Then we have the more obvious culprit, like the loss of ice. This is basically something we refer to as post-glacial rebound, where the loss of ice is supposed to accelerate the rotation of the planet. And that's because North and South Pole rebound from the loss of weight, making Earth just a little bit more spherical and causing it to spin just a little bit faster. Or at least that was the assumption from before. Turns out some of the recent research found something a little bit different. Here, massive amounts of ice melting in Antarctica and Greenland seem to potentially cause the opposite effect. Mostly because it doesn't seem to affect the shape of the planet, but it does seem to affect the angular momentum due to the loss of ice. And so there's actually a chance that maybe because of loss of ice, Earth has actually been slowing down its rotation a little bit more than it should, counteracting forces speeding up Earth's spin. And then we have the other culprit, various massive eruptions and global events. Any kind of a large-scale event that affects an entire region can usually shorten the time as well. For example, the 2004 Indian Ocean earthquake shortened the length of the day by approximately 3 microseconds. But even human activity that redistributes water on the surface, such as the construction of the Three Gorges Dam in China, has been calculated to increase the length of the day just a little bit. And so in short, lots of different potential explanations, but nothing concrete yet. As a matter of fact, it's possibly a bit of everything. And so alone, none of these oceanic or atmospheric models explain anything yet. But this does highlight how complex our planet truly is and how much we're learning about it by observing these individual changes. Although importantly, right now it's basically impossible to predict how the spin of the planet will change in the next few years. As a matter of fact, it's entirely possible that this current acceleration is just a temporary fluke, and all this will reverse and go back to normal in the next 3 years. But here it's super important to highlight that none of this really kind of matters for us. So basically this is not some kind of a doomsday scenario or something super dramatic that's suddenly going to collapse the entire system. This is just something natural that happens at these extremely tiny increments of time. This is not a dramatic change at all. This is not going to lead to any catastrophes. And it's something that's been happening for a very long time. As a matter of fact, modern technology can easily adapt to these changes, despite previous warnings comparing this to the Y2K bug. And so here this is really more of a theoretical and scientific curiosity, because it pushes the boundaries of our understanding and of course our engineering capabilities. It's also a testament to the incredible precision of our scientific instruments, because here we're able to detect minute changes on the entire planet. But also a reminder that even something as fundamental as the length of day is not fixed, but extremely dynamic, always changing, always being influenced by forces within our planet and even outside our planet, and always transforming and never standing still. But because this is such a curious phenomenon, it would be interesting to find out what's really causing this and what's creating this somewhat unusual anomaly. And if you have an idea, post it in the comments below. Anyway, a pretty unusual phenomenon that we've discussed previously, and something we'll definitely discuss once there's a definitive answer and an actual study that finds the exact source. And so until we learn something else, or until we have any updates about this negative leap second, that's all I wanted to mention. Check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support the show on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt. Thank you for watching, stay wonderful, I'll see you tomorrow, and as always, bye bye.